Okay, without further ado, we'll get started. So first up we have Tennessee Leeuwenburg. Tennessee's been extremely active in the Melbourne Python user group and is a scientist, data scientist, software developer, manager who works at the Bureau of Meteorology. And his talk today, as you can see, is data science design patterns. And without further ado, Tennessee.
Thanks very much for that Graham. It's a lovely introduction. I always feel a bit uncertain about how to approach a presentation. I feel like I have to pick somehow the middle of a very long conversation and try to pick an end point within 25 minutes that makes sense. So what I've done is more or less just start and we get where we get in terms of the content. And I've got less and less interested in lecture-style presentations as time's gone by, so anyone who wants to enter into kind of conversation, debate, discussion and such like, as far as I'm concerned, that's all completely fine. So probably to initiate that, I've got a slide in 2 slides' time where I put down what I think it is that you'd like to hear about, but I'd like to know if I'm right. So I'd like to know, does anyone happen to tell me what they think I'm going to talk about when I say a data science design pattern? No, great. I've got a room full of people who aren't here to think. I can now proceed just fine. Okay, so no one's going to question it. It's great. Okay, so about me, I was a coder once and I still tinker actively. I've seen a lot of applications and systems, including data science-y ones. And that's the little nugget I picked up on like what it is that I could possibly have to say that hasn't been said on the internet enough times that you are all either more expert in me than me in, or could simply read for yourself elsewhere. And I think what it is that I've seen them in a number of contexts: the research context, the operational context, the 2-day hackathon context, and I feel like I don't know whether I've learned anything exactly, but I've experienced a fair amount of the pain, and I can tell you what that is. So that's where I'm going to concentrate my talk. So this is my slide that I was going to talk about before in terms of what I think this audience is here to hear. So I think we're all interested in Python. I'm somewhere in the middle between solving data science problems and making software to deliver solutions. So that's kind of where I sit, is kind of squarely in the middle. And my great fear is that the entire audience is either entirely demographic or 50% non-intersecting demographic 1 and demographic 2. And what I have to do is give 2 presentations to 2 separate audiences in the same room. So that's my working theory with the rest of this presentation, is that I actually have 2 presentations, and if you could all kindly just collect yourselves into that half of the room, we'll all discover whether I'm right. But we've already established that you're not here to think, so it's all good. Okay, so what do design patterns do for you? So this is probably this is for the data science, this is for demographic 2. What do they actually do for you? So they do, at least in theory, once you know them, make the work easier. And for demographic 1, that also applies. So the question is, it either does that in the data science-y bit, solving the data science problem, or in the software bit, or conceivably both at the same time. So it'll allow you to turn your data science into software and make your software more standard. So it'll allow you to integrate and make tools that everyone can just pick up and use everywhere easily. For those in demographic 2, it assists with giving you a starting point and making more rapid progress in your problem solving and making software or experimental code that's going to still make sense to you in some time to come. So let's start with a bit of a formal definition. So software engineers get to own the word design pattern, and I think that they still manage to claim that definition. So it's a general repeatable solution for a commonly occurring problem in software design. A design pattern isn't a finished design or even an implementation. It's more just this kind of thought. So no one really seems to have been able to nail it down a little bit harder than that. So I decided to de-jargon it for you. It's when some code is so great that you give it a name. Okay. So why do we use that? Well, actually, you know what? It kind of isn't really when the code's so great. It is when the design is so great. And the reason you want to concentrate on the design more than the code, is because we all want to be able to talk to each other. And some of us use different languages or different implementations, or we've got different experiments and we need to relate them to one another. And the best thing we can do is try to reduce the degree of confusion amongst all of ourselves. So if you're working in an entirely isolated experiment, you'll see design patterns mainly through the tools and libraries that you use. If you're trying to convert someone else's experiment into a working piece of software, you'll be very grateful if they've taken the trouble to understand some of the design patterns of the software world. And if you're wrangling a portfolio of applications, you will discover that they all have their own unique and beautiful view on how software should be built, constructed, and interoperate. So we use them to make more readable, more comprehensible code. So it's about good code, to see our problems in a new way or from a higher level. And I think the language thing is probably the main one, and that's a human-to-human talking, but it's also like the implementer from 3 years ago to the fresh developer now kind of conversation. Both of those things go on. So I really wanted to get in and make this a bit exciting. So I thought, let's play a game. Who wants to play a game? Yay! Okay, hand raising. Okay, so I can use hand raising as an input-output mechanism to communicate with my audience. That's excellent. Okay, so sticking to a strict binary language of communication here, hands up if anyone thinks there's a design pattern in this that they recognise. 2? Hey, so we've got some people. So let's work out if it's the same one that I thought was in there. So I think the design pattern in here is a builder design pattern where you use a function to return an object rather than a constructor. Anyone? Did anyone choose that particular design pattern for what they saw? No. What did anyone else pick? I'm sure there's more than one answer. There's always more than one answer. No, hand raising it is. Okay. Is this good code? I agree. I think this is bad code. Let's see if we think it's bad code for the same reason. I actually don't think it's bad code because it's called do magic in the middle. I actually think there's a different reason that it's bad code, although that is possibly also bad. I think it's bad code because you're reading from something and then you're not writing to it. And you know what this does is that every time I use this library, I can't remember which one's from and to, and which one's read and write, and every single time I need to use pandas for the first time in 2 weeks, I need to look at the documentation, and it's annoying. So that's not exactly a design pattern. So the design pattern in there is the way the object is constructed. So for people for whom the code that's going on is the piece of information that's in their head, not the design, not the data science, not the fact that Pandas is fantastic and a library full of wonderful tools that just do amazing things for you, but the people who are thinking about what's going on in the memory and the state of the program and how they're keeping track of their objects and making sure that everything's got integrity in memory. The issue is there's no constructor here. What we're doing is reading CSV, we're calling the pandas general module, it's under the hood creating something that's a constructor. We don't know what arguments that constructor has. We don't necessarily know without looking through the docs exactly what comes back just in advance. So we may, and then there it is, and then when we write it out again, instead of doing it again through the same idiom, which is through the pandas library, we're now doing it off the object. So for people who are highly focused on the semantics of the API, this would be like super confusing. And the only reason it's not confusing to everyone here is because pandas is fantastic and we all know exactly how it works. Okay, so let's pick another one. All right, hands up who sees a design pattern here? No, we're all scared by the last example where I picked a different one. So, okay, so I see a design pattern here. The one I see is a pipeline. So what we're going here is we've got this thing called a model, and it's this sequential thing, and the first thing happens, and the second thing happens, and the third thing happens, and the fourth thing happens. And this is effectively the same thing as a kind of like a Unix pipe philosophy. What we're doing is declaring a one-way workflow. So we kind of get the impression from what's going on here that, you know, because it's sequential nature, there's probably not a whole lot of backwards data flow. I mean, to some extent, it's a neural network, and there will be. But what we're talking about is the way we construct what we've got in memory. Is this linear concept? There's a data pipeline. We're trying to get towards an outcome. And so that's the design pattern that's going on here. So this is where, by good fortune or clever design, this kind of design pattern kind of instantly makes sense. You don't really have to think too hard about it. You understand that, the data hits the model, and the first thing that happens is there's this dense layer that the data gets fed into, and then this activation thing occurs afterwards, and the semantics are really pretty clear. And using terms like sequential to call out the nature of the calling function helps us understand, without even really having to think about it too hard, exactly what's going on. So I like that particular code. Okay. All right, hands up who can see a design pattern in here. I'll give you a hint. It's inside the big grey box. Okay. So one person before the big grey box identified a design pattern. So again, let's play the game of picking, did you pick the same one that I picked? So the design pattern that I picked here was the strategy pattern. So essentially what's going on here is this library here is able to make different choices on the fly through an automated pipeline about what's actually going on here. So it may choose, for example, a different modeling algorithm to use. It may choose a random forest one day, or a neural network the next, or a state vector machine the next, or something of that nature. It may walk through different parameterization schemes automatically. And so what that's doing is it's giving the computer the ability to make its own decisions about how to even process what's going on the fly. And that's generally referred to as the strategy pattern. So I highly doubt that anyone in particular, when writing these things in the first place, started with a design patterns book. I'm sure that this is more the result of just generalized thinking about software over time. But what it means is that when we get these fantastic libraries, they're more likely to interoperate or be able to be adapted to one another if we can understand the design patterns and understand the thinking of how the software gets put together. And this is also a really interesting library. So I don't know whether, for anyone who's a bit of a machine learning tinkerer, this thing called Teapot was produced by Randy Olson, and effectively it's the unthinking engineer's approach to finding a data science solution. So you can use this to do effectively not merely a grid search of your parameter space, but it also allows you to choose different models and optimize according to effectively a genetic algorithm approach. I haven't used it personally, but I've gone through the podcast, and I think this could be, what he said is that it is an effective way for finding a useful starting point, and I think that's probably actually very true. So it's one of the things in my back pocket to pick up and try one day. So, bonus question, the difference between an idiom and a design pattern. Who thinks there isn't a difference between an idiom and a design pattern? All right, so if I take the complement of 0, 100% of people think that these things are different. Okay, so that's good. You're all correct. Good work. Okay, so what do they have to do with each other? Do you think that the idiom has a relationship with a design pattern? 1, yes. Give it 2, excellent, brilliant. You're both right. 98% of people were too lazy to raise their hands. I can draw the correct conclusion. Okay, so the fuzzy thing is what they have to do with each other. So if we go back to our definition, we know they're not the same thing because the design pattern really says very clearly that it isn't about code. And an idiom is really about the translation of a design pattern or whatever we happen to be thinking at the time, one of the two, into an implementation. So insofar as they relate to each other, it's the difference between more abstract conceptualization of what's happening and the implementation at hand. And because the programming language affects the way that you can express things, it affects the ways in which you realize the design pattern and to some degree whether you even need to. Python, for example, has natural language semantics for the singleton pattern, which is the module. There's only one thing in memory going on at once. You change it, it changes everywhere. whereas other languages you may need to actually construct a class or construct implementation logic that provides that guarantee for you. So what does Python have to tell us about good code? So we've said that design patterns are about good code, and we've said idioms are about good code, and we know Python's all about good code. So Python comes with a kind of a rule book, and they don't bother talking about design patterns or idioms or any of that abstract malarkey that you get taught in a comp sci degree and never really use again, potentially. So it has this sort of set of kind of principles, really. And I don't really know exactly how this relates to either design patterns or implementations exactly. A lot of it's this beauty is in the eye of the beholder thought. I mean, there are plenty of talks out there that discuss what particular software engineers interpret this as. I think that what it tells us is how to translate thoughts into Python most effectively, but it doesn't really tell us how we should design. So I think a design can be beautiful or ugly. I think that a design can be explicit in the sense of you actually write down what your design is separately from your implementation, which is something I'm still struggling with. I think that many of these concepts apply equally as much to the idea of design as they do to a language. So I'd encourage everyone to sort of think about it. Now, we'll get into a bit more sort of data science aspects of this in just a minute. But one of the things I struggled with this whole talk was kind of, you know, what's the pitch? And it goes back to some of these examples about things like you know, NumPy. Everyone has picked NumPy because it just works everywhere. Everyone's picked pandas because it's very powerful and it's got just enough NumPy under the hood that you don't really have to change your worldview very often. So we've got these design patterns of data science. What are data science's design patterns? And you know, what are they? How should we think about this in the domain of data science? So here we're back on, I've just been waffling about all this demographic 1 computer science stuff. Now we're back into demographic 2, the data scientists in the room. So these things are very likely to be highly familiar to many of the people in this room as the basic things that we work from. So when does design come into these concepts? So the first thing I want to do is a bit of anchoring and just put this slide up because it's all about the data science domain space, and then ask a few questions, hypothetical questions using only hand raising required from small numbers of people in order to proceed with the Q&A session. So this is what would be effectively some kind of description of the general significant concepts involved in many data science problems. So this would probably be where your head is at when someone asks you to implement a particular feature or solve a particular problem. So here's a spot quiz. So I thought, well, I'll come up with a hypothetical example and then talk about how we do work on an example like this, and where does designing fit, and where do design patterns fit, and what can we do with them. So hypothetical, I'm a researcher. I'm really not, so I've started badly. But if you can just pause your disbelief for a moment and imagine that I'm a researcher on conversations, just in general. I'm researching conversations, and I have a large body of text which includes conversations in it, and I need to write some intelligent search, and I need to be able to find things about conversations, and I've got a bunch of Word documents because everyone knows that's the natural and true format for all documents. And there's some photos in there sometimes, you know, just sometimes, and they're not labelled. So what I'd really like to do is effectively just like Google over my Word documents, and I'd really like it to just know about conversations, and I'd like to be able to search on the semantics of who said what to whom and when and why and about what. And sometimes people are talking to each other, and sometimes they're talking to each other about other people, and when they're talking about other people, those other people are the topic and not the subject, and such like. So how do I do that? So what's the first thing you do? Don't we all know this? You Google for it. Okay. What is the second thing we do? You Google for how to do part of it. Okay. So what's the third thing you do? You look for libraries that already do it, and then somewhere down there you go, okay, I think I can cobble together pieces of this. So there's been very little design going on so far. There's mainly been, I don't know, that kind of lost phase at the beginning. I don't really know how to, they didn't teach me that in computer science, but they should have. It's everywhere. Okay, so then we start growing a solution, then at some point we start to understand how our problem domain and our software goals and the requirements and the libraries all kind of come together, and we've got this sort of like mishmash of like some Jupyter notebooks and some code and some Word documents that are an incomplete data set because complete data sets are too big, and some ideas, and we need to start stitching it together. So we need to work forwards and backwards through the business problem and understand the business rules, and we've got to like model all of these things and come up with some ideas and come up with an experiment. So what's the one design pattern that we all know about? It's the adapter pattern. That's what cobbling together things is called in computer science. So what is an adapter pattern, and how do you do it, and why would you do it in an organised way rather than in a, well, I'm just going to have this big sequential 500-line block of Python code where everything just sort of flows into each other. So essentially what it does is it lets you hide all of your bad code. The fundamental goal of the adapter pattern is to hide bad code in a library where people don't know that you've written it and bring the business logic to the fore, such as do magic. So do magic is effectively like do all of the business logic, and then you can write all of your methods like, you know, search between person A and person B, and the fact that what you're doing is loading Word docs into a library, using the clipboard to extract from there, and then paste it directly into a string IO, and then feed that into NumPy and initiate pandas. All of that is adapted, and all of the business logic remains. And almost no matter how terrible your implementation, all of your software engineers will thank you, because what your program is supposed to do is what's left. Okay. And that's what the software engineer. So now we go back to demographic 1. So you've managed to explain that the adapter pattern has something to do with hiding away the horrible implementation details and concentrating on business logic. And now your job is to make software out of this stuff. And so where the data scientist has been working forwards and backwards through the business problem, your job becomes working sideways. I need a GUI, I need a web server, I need a database because the local CSV file's gotten out of hand. Actually, I need 3 databases. Oh wait, now I need security. Uh-oh. So then you need Active Directory integration, and then you're just lost forever. So you need to know about how to construct the code in memory and the APIs and start integrating it with other systems. So your interest is to get the data scientists to hide all of their implementation so that you can either re-implement or ignore and be able to integrate more directly using common features. And that's largely what NumPy has done for the scientific community by providing a universal data encapsulation for everything. Now, like I said before, I don't really know how to end presentations. So we've got to my last slide in the next slide, and here it is. So I don't know whether I've encouraged you to know more. I don't really know if I had a point, but I have run out of time. And so thank you very much.
Okay, well, thank you very much for that, and I hope that the oh, look, there are hands already. This is amazing. Yeah, so I will hand over for questions.
Hi. So to my mind, the prototypical design pattern is the scientists throw it over the fence at the computer scientists try and catch it, and it sounds like the idea of design patterns itself is actually some sort of tunnel under the fence.
I think that's an organisational design pattern as well. Look, broadly, but the idea is that hopefully it gives you some common framework so that, yeah, I don't know, maybe you're passing it to each other through a hole in the fence that's about the same size. I'm not really sure how to carry the analogy much further.
Any other questions? Yep.
So on organisational design patterns that software developers and scientists working together, are there things that you've seen work really well or things that fall down and should be avoided?
Yeah, look, so I have seen a bit of that in my time. I think the thing that works the best is where you have one person responsible for effectively API design and identifying good code and giving it somewhere to live, and another person on basically hacking around in Jupyter notebooks and doing implementations, but doing that in a pretty free-flowing fashion so that you have some conversation around it, and that seems to have worked okay. Having them all work in the same language is pretty important, and Python's quite successful at allowing people to work in the same language. Yeah, I think those are probably it. Thanks.
Hi, great presentation, by the way. You mentioned the adapter style of design as sort of like the basic one that most people do if they have like a deadline. Is there like types of design styles that are more efficient or people should start looking into?
Yeah, look, that's a great question. So for an example of using the adapter pattern properly, because Python has a lot of support for that, like, context managers are a great example of how you can use the Python language semantics to implement one of these design patterns. I'd start with that first YouTube video. That illustrates the concept of focusing in on business rules and pushing away implementation logic really very well. In terms of things where how would you write a program to minimize the number of newbie mistakes or a common denominator that works for everyone or places to start? I would generally go with something fairly functional as a rule. Try to make your calls as transactional as possible. And even if you have a class or object structure, within that, try to adopt a functional style within it. So try to avoid methods that have significant amounts of side effects. Don't have them do too many things at once. Don't have them be too long. And generally separate out the bits that are the business rules away from the other stuff. But that functional approach will effectively make it much easier to test going forward. And it also has this side effect where you'll suddenly discover that a lot of your methods actually don't need any of the class objects in order to do their work. And so you can start moving them out of the class, and then you suddenly realize that you could still use them from within the class, but what you were thinking about as a complex object actually kind of falls away a bit, and it can kind of reveal the true nature of what you need in the class a little bit more easily.
Are there any other questions for Tennessee? No, we're all out of hands. Well, we're back here at 10 past for the next paper. So if you would like to thank Tennessee again for his presentation.